0, Appendices E and F. And we call this our pre-proposers conference. It gives you an opportunity to hear what we're thinking and also to ask us some questions before we open up the solicitation. Next slide, please. So really, this conference is intended to clarify the solicitation. Again, like I said, to answer any questions that you may have. It's an opportunity for us to have a little back and forth. Once a solicitation is released, it's difficult for us to answer specific questions because it could give people an advantage over others. Any information that we give out would have to be given out to a larger audience. And so this is a great opportunity to have that interchange. It is open to all. The Q&A and the discussion will be accessible to all attendees. Everything will be posted on this website here, the Inspires website. And then if we have any questions that we have to defer where we don't have the answer right away, those answers will also be posted on that website for everyone to look at later on. Occasionally, if you ask a question that's something we didn't have prepared or we didn't foresee, we may have a private sidebar where we'll silence and we'll discuss and then give you the answer. Again, as I mentioned, some questions may be deferred, but those will be posted so that everyone can see the answers. Next slide. So just a little background on the Human Research Program. We are an applied research program. We're not NIH in space. This is important for people to realize, especially if they have not written for NASA before, because of the constraints that we have. We're very focused on the application of spaceflight on the human. And so we're specifically trying to address risks. When we release the solicitations, they are specifically addressing risks, and the responses that we request must address them as well. If not, then we will consider them to be non-responsive and they will not be reviewed. But what we do is we perform the research necessary to understand and reduce the risks to the human of long duration spaceflight, or actually any duration spaceflight. We enable the development of human spaceflight medical and performance standards. These are things like CO2 exposure, radiation exposure, nutritional requirements, exercise requirements, those types of things. Those are developed by various groups, and the work that we do in the Human Research Program is used to develop those standards. And then finally, we develop and validate technologies that can be used to both characterize and reduce those risks. Think of things like next generation ultrasound, the ultrasound machine we use on the space station, or potentially other vehicles. Generating sterile saline in flight. How do you do CPR in flight? All these different things have to come from somewhere, and so we do the research that helps us either fly those technologies or understand them better. And here are some examples of that you can see in the pictures. Next slide. So these are our planned research activities, and really it comes in 3 phases. And so Earth, we simulate spaceflight hazards using various ground analogs. The NVHAB is a bed rest facility in Cologne, Germany, that we use as our bed rest facility. This is a particularly nice facility because not only does it have the beds that we need, but also it's within an atmospheric chamber, so we can change the atmosphere while we're doing that bed rest. We have a fair amount of research going on at several different Antarctic stations. We have isolation work going on at the NEK, which is a facility in Russia, and that's a longer duration isolation facility. And we also have work going on at the Hera, which is a shorter duration isolation facility that's located here at Johnson Space Center. And then the Space Radiation Laboratory is located at Brookhaven National Labs, and that's where most of our radiation work is done. We also do a lot of work in low Earth orbit aboard the International Space Station. There we can look at microgravity and various environmental hazards. It's impossible to perfectly replicate microgravity here on Earth. You know, some of those analogs can do a little bit, but really the best way to study space is in space. And so we use the ISS as an analog for future spaceflight, whether it's Moon or Mars. And then finally, the lunar missions. Artemis is how we're going to get there. Um, Things that we're trying to work on, decreasing the dependence on Earth, so becoming more autonomous. Then we have landings on the lunar surface, the first woman and the next man to land on the moon. There are many different things we can do here, and we're looking forward to doing that research as well. Things that will be very important to us: radiation, behavioral health, and then gravity transitions, going from 1G to microgravity to lunar gravity, back to microgravity, and then back to 1G. What are the stresses that that's going to put on the human body? Next slide. So just to describe the human research program in a little more detail, we're composed of 5 elements. You can almost think of the elements um, as research departments, if you will. And each one has their own specialty. So exploration medical capability, they look at medical care for deep space missions. We often call them the pointy end of the stick. And they're the ones who do a lot of the technology development that I mentioned. Human factors and behavioral performance, I believe Dr. Whitmire is online. So Sandra, would you like to say a few things about your element?
Yes, hi there. Thank you, Steve, and good afternoon, everyone. Yeah, so I'm Sandra Whitmire. I'm the acting element scientist for HFBP, and our element manages several risks, including the risk of adverse behavioral conditions resulting from spaceflight stressors, such as altered gravity, space radiation, isolation, confinement. We also work to reduce risks relative to sleep, fatigue, human systems integration, and also mitigating negative outcomes due to changes in team dynamics for exploration. And we're a performance-oriented risk, also concerned about long-term health outcomes. Thank you.
Thanks, Sandra. Our next element is human health countermeasures, and I believe I saw Dr. Stenger online too. Mike, would you like to say a few things?
Hi, yes. As our name implies, we're interested in most of the physiological systems of the human body, how they react to space, and we develop countermeasures to any negative or adverse effects that we see. We're broken up into 3 primary different groupings. One is our exercise and performance group, where the disciplines are things like exercise, bone, EVA performance, and sensory motor alterations. And that's tied to our one of our calls in this solicitation. Our second one is the cardiovascular and SANS grouping, which is the spaceflight-associated neuroocular syndrome. And then our third is a multi-system, including the immune group, microbiology, and the food and nutrition disciplines.
Great, thanks, Mike. Space radiation. I saw Robin online. Robin?
Hi everyone, I'm Robin Elgart. I'm the space radiation element scientist. Space radiation element is really responsible for characterizing and facilitating the management of human health outcomes associated with space radiation exposure to protect astronaut health and well-being and enable human spaceflight. The primary risk that the element is responsible for is radiation-associated cancer, but we also contribute to and provide subject matter expertise for this cardiovascular disease and degen risks, as well as these BMED CNS risks, both in terms of in-mission and long-term health.
Thanks, Robin. And our final element isn't a research element per se, but they actually enable the research to be done. Dr. Vesey, I saw you online. Would you like to say a few words?
Sure, thanks, Steve. I'm Brandon Vesey, the acting element scientist for research operations and integration. And as Steve said, we're a little different from the other research elements, where our primary focus is on actually implementing and integrating the research into those different environments that Steve mentioned. between both spaceflight and the analogs. So we're working with the other research elements to take their studies and study requirements and implement those into the different facilities that HRP works with.
Thanks, Brandon. And Chris, I'm sorry, I didn't see that you were online before. Would you like to say a few more things about EXMC? All right, not hearing from Chris, so I'll move on to the next thing.
Chris, are you muted?
He may have had to step away. We also fund the Translational Research Institute for Space Health. We call them TRISH, and that's through a cooperative agreement. And what TRISH does for us is they act like our skunk works, if you're familiar with the term. So they go out and look for high risk, high reward research, things that NASA, might not typically do as a government entity, but they're out there talking with venture capitalists, looking at really innovative work, and they do some fantastic things for us. They put out their own separate solicitations, so they're a good group to look for. And then finally, we collaborate with other government agencies and other NASA programs. We work with NIH, CDC, NSF, the whole alphabet soup, pretty much. Anyone like that we've probably worked with. One thing I'd like to highlight is the work that we do with space biology. There's an experiment called VEGGIE where space biology is flying crop plants aboard the space station with the idea that we would grow plants while we are going to Mars. And so what space biology is concerned with is how do you get the plants to grow? How do you package the seeds? What kind of soil substitute do you use? What's the watering system? What we're really concerned with is how do we use those as a countermeasure, right? So we're growing those plants. Growing plants is something that a lot of people do as hobbies, and that can be a positive countermeasure for the crew. Another positive countermeasure is having a fresh salad in the middle of your mission. So getting to eat those leafy greens or tomatoes or radishes or whatever we're growing at the time is another countermeasure. And then also the nutritional benefits that you might get from having fresh food during a mission. So, we try to do as much work like that as we can, work where we leverage what other groups are going to do in order to get a bigger bang for the buck for the research we're paying for. Next slide. As I mentioned, we do research in a number of different places. Obviously, the International Space Station on the top left, and there's the NVHAB that I mentioned and the NSRL. We also do sponsor work on parabolic flights, and these are run out of France, and we have several of those in the planning stages. On the bottom left, you see the HERA, the short duration isolation analog that we have at Johnson Space Center. And then on the bottom right, the NEK, the longer duration facility that we use in collaboration with our Russian colleagues in Moscow. And then finally, Antarctica. I think we have work on 3 stations going on right now. Next slide. And the way that we parse out our research and decide what to do is we have assigned risks. And then within those risks, we also assign the likelihood by consequence. We call that L by C. So red is the highest risk, yellow is medium risk, and green is a low risk. And what we're illustrating here is, if you look down the far left column, those are all of the risks, and they're divided up by hazard, spaceflight hazard. And then the columns you see are the different design reference missions, or what we call DRMs. The far left is low Earth orbit. Then we have lunar orbital, then lunar orbital plus surface, and finally on the far right is Mars. So you can see we have more red risks for the Mars DRM, and that a lot of that has to do with distance and time, as well as radiation. And so this is just to give you an idea of what the distribution of those risks are and how we decide what research to solicit and when. Next slide. And so NASA, we have a number of program constraint and goals that most folks aren't really going to be aware of if they're not familiar with our program. So we have constraints on schedule, crew access, and our focus on risk mitigation that's different from NSF and NIH, right? We have very low N experiments if you're doing human research, whether you're trying to do it aboard the space station where we have limited access to crew, or if you're doing it in a isolation facility where we have, again, we have a finite number of test subjects. Typically for a HERA campaign, we'll have a maximum of 16 subjects. And so you can see all this low N work. Our constraints on schedule are, we have lunar missions that are departing on certain times. We have ISS missions that are departing at certain times, and we don't have controls of those schedule. So we have to do the research necessary to make those flights safer on those schedules. And so for some of these reasons, our investigations should significantly contribute to the risk reduction focus of HRP. That means that some of the work that we either solicit for or select may not be the most highly innovative work, but it's focused on our risks. So risk is most important to us. Although, everybody loves innovative work, the work has to be cutting edge. But again, that focus on our risks is a primary concern for us. Next slide. Again, because most of our studies are low N, statistical considerations are particularly important. It's important to have a robust statistical design for the experiments to make efficient use of the low N. Our small N studies won't always achieve the ideal sample size. So it's important that the investigator understands statistical power, control of extraneous variables, margin of error, these types of things. The proposed sampling procedures, experimental design, and data analysis methodology are very important and will be evaluated by a statistician as part of our merit review. This is so important to NASA that we always have at least one statistician on each peer review panel. Sometimes we have two. Step 2 proposals must include a dedicated section describing the statistical approach or a strong justification for not needing one. Next slide. So just to give a brief overview of the solicitation process, it's a two-step solicitation. Step 1, proposals will be submitted to NASA, and they should include a synopsis of the intended research. The page limit for this synopsis is 1 page. Those are due by the 30th of April, 5:00 p.m. Eastern Standard Time. The Step 1 proposals must follow the specifications listed in the solicitation. I can't say this enough times. Please make sure you read that solicitation very carefully. We have many, many grants that are submitted that don't follow the solicitation, and unfortunately those are typically not reviewed. Only applicants who submit relevant Step 1 proposals will be invited to submit the Step 2. Step 2 proposal window opens on May 28th. If you are invited to submit a Step 2 proposal, those are due by July 29th, again at 5 p.m. Eastern Standard Time. The page limits for the central scientific and technical description are 10 pages for Appendix E and 5 pages for Appendix F. Step 2 proposals for both appendices will be reviewed for scientific merit as well as for programmatic relevance. The merit peer review will be conducted by a panel of scientific and technical subject matter experts that's independent of NASA. We don't pick those, and we don't run those reviews. NASA will evaluate the programmatic relevance, the feasibility, and the cost of those proposals separately from the merit review. And then the final award decision will be announced by December of 2021. Next slide. So for Appendix E, there are two topics. The first topic is manual control countermeasures, and this topic has a grant award of up to $800,000 over 3 years. Sandra, would you like to say a little bit more about your manual control solicitation topic?
Sure, although this is really led by HHC and sensory motor.
Oh, I'm sorry.
No, that's okay. But it's a good partnership. So, but I can certainly start. I just don't want to steal Mike's thunder. But essentially, we're looking to gather countermeasures relative to mitigating manual control decrements that we anticipate during G transitions. So there's a write-up in the topic that you see there, providing some supporting evidence and sort of linking some of those outcomes to other issues relative to cognition and biomarkers. And so the focus is that set of countermeasures. And showing how these countermeasures can prevent or reduce the risk. Mike, I don't know if you want to add anything to that.
Hi, I just wanted to call everyone's attention to the research platform itself. NASA is working on an agreement with the United States Navy to use the disorientation research device at Wright-Patterson Air Force Base, also known as the Kraken. And if you were to submit a proposal using that, there's no need to include facility costs. Those will be covered, but you're more than welcome to use your own motion base if you have access to one, but those costs will be on you. Thanks, Sandra.
Thanks, Mike. Sorry about that. I don't know why my brain assumed that was Sandra's topic. And I know about the Kraken because that's just too cool. Release the Kraken. Our second topic is computational brain modeling to characterize the effects of space radiation exposure. And this one is up for $250,000 per year for 2 years. And I hope I'm guessing correctly that this one is Robin's topic,
Yes,
space
thank you,
radiation.
Steve.
It's one of
Yes.
those days.
Oh, I hear you, man. So my partner in crime, Janice Zawoski, or Jay-Z, is not here, and she really is the brainchild, no pun intended, behind this one. But so I'm going to do my best today. But really, what we're looking for here is there have been some really interesting computational sort of models that look at brain structure from the network sort of level. And so we would love to see how the different kinds of radiation that we are expecting to be exposed to in space, namely GCR, which is made up of protons and heavy particles, how those different kinds of tracks may affect the network stability of the different networks in the brain. If you have a track going through specific different modules in the brain, is that going to impact that brain network to a point where we might see a decrement in terms of performance or function? And so really we're looking for more of a computational proposal here, which is a little bit different than what we normally do. So we're not anticipating, rats being exposed at NSRL or anything like that. That's not really what the expectation is here. This is more of a computational platform looking at the different tracks of radiation and how that overlays with the different networks in the brain and how to translate maybe between species as well would be super cool. So yeah, there's my little soapbox.
Excellent. Thank you, Dr. Elghart. Appreciate that. Next slide, please. And as always, we have the Appendix F Omnibus proposals. This time there's something a little different. So if you're used to hearing this, there will be some new information coming up here for you. If you're not used to it, then the Omnibus solicitation is a really interesting opportunity, I think. These are short-term investigations or technology development projects that provide innovative approaches for any of the risks and associated knowledge gaps. Right, and so that's very important. So for an omnibus, for Appendix F, you do not have to answer for one of the two topics that we just talked about. These can be directed at any of our risks. The first one, a general omnibus is typically $150,000 per year for 1 year. The new investigator opportunity used to be called a Binney Award, but we changed the name because we didn't think a lot of people were understanding that it was designed for new investigators. And so what we mean by a new investigator is a PI who has not had HRP, EPSCoR, or TRISH funding, or actually NSBRI as well, funding in the past 10 years as a PI. If you're a co-investigator, that doesn't count. So the reason this is of benefit is they're scored separately, and so there's a slightly different way that folks look at it. It's designed to be innovative. It's designed for newer investigators, and the possibility exists for a second year of funding. So it could be a 2-year study for up to $300,000, depending on progress of the study. The new award, so we just started this one recently, is called the Early Career Investigator, the ECI. And this is also for a PI who has not had HRP, NSBRI, EPSCoR, or TRISH funding in the past 10 years. But additionally, it's for a PI who completed their terminal research degree or end of their postgraduate clinical training within the past 10 years. And again, these are designed to be more innovative. You do not have to specifically address a risk even for these, either for the new investigator award or for the early career investigator. It just needs to be spaceflight relevant. Now remember, you're writing it to NASA and HRP and to the elements. So if it's too far out in left field, it might be difficult for an element to justify spending money on it in these days of a tight budget. But you have lots of leeway within something that's spaceflight relevant, looking at our risks, looking at our gaps, and all of those things to write some very innovative, very thought-provoking, interesting research. And again, for the early career investigator, that opens up the possibility of a second year of funding. So possible $300K total. Next slide. And it looks like that is the end of our presentation. So Ben, how do you want to do the questions?
So the plan is to basically go the way we did before under the old platform, which some of you all who have attended these before will remember that was Adobe Connect. But essentially we are going to take questions in the chat, and then our NASA representatives here will answer them in voice. We do have recording, and we'll be transcribing the answers and possibly updating ones if we need to afterwards, and posting it all to Inspires. So.
Okay, the first one I see is from Allie. Does Appendix F not accept PIs who have had previous awards? A regular omnibus does accept PIs who have had previous awards. The New Investigator Award and the Early Career Award do not. Will the slides, this is from Susanna, will the slides be available for download later? Ben, they'll go up on your website, is that correct?
That is correct.
Okay.
Steve, this is Mike.
Hey,
There
Mike.
are some earlier questions in there in the chat.
Okay.
One of them was, does the one-page limit exclude a list of references?
I believe references are not included in that page count. Kat or Manish, is that correct? I think that's correct.
As a step one, my advice would be that you don't require references. This is for relevancy only. I would vote you kept everything under one page.
That's the way we've traditionally done it in the past.
Okay, great. From Melody, sorry I missed these earlier. Is the current omnibus call open to anyone or just new PIs in early career? No, it's open to everyone. The regular omnibus call is open to everyone. And then there are separate subsets, subcategories under new PIs and early career. The decision on the step 2s. So typically for the Appendices A, we typically don't get resubmissions of those because those are the ones under the call, but for the omnibus we might. Kat, do you know when these are planned to be announced?
Step 1. Can you hear me? I believe I'm on.
Yeah, we can hear you. The step 2s for the last call.
The step 2s for
For A
Appendices
and B.
E and F, A and B.
Mhm.
Let me check that really quick and I'll get back to you.
Okay.
I can help you there, Steve. The answer is probably not. I imagine you're going to issue the awards announcement right at the same time that the step 1s would be due. So, my advice would be that they should just submit without that knowledge.
Okay. Sounds good.
Another question that we have from Dave Miller, Steve, is can I submit both Appendix E and Appendix F proposals?
Yes, you can. They just can't be the same proposal.
We have another question. Do I need to specifically indicate new investigator or ECI status on my application? I believe that is correct. Does anyone else have any input?
Yeah, isn't there a checkbox in the paperwork?
The first
Exclude.
program is specific data question allows you to select the risk you are addressing, or if you are doing a new investigator or early career investigation, you can select that.
Mm-hmm. Great. From Luke, in general, is there a definite description for the scientific approaches, animal, human, in vitro, in vivo, or is it merely depending on available technology and whatever gets the results? Do any of the element scientists for solicitation topics want to address that?
I'll go for mine. It depends on whether you're talking about the flagship or Omni, but of course for our flagship, this is Robin from Space Radiation. For our specific flagship, really we're looking for something more computational, so that'll depend on the available technology. But generally for our Omnibus solicitations, usually those are, given the small dollar amount, very few of our omnibuses are typically animal. We don't have a definite prescription though. In radiation, we have very few possibilities to do human. So usually ours are in vitro or in vivo. But again, it just depends on what you're specifically soliciting to do and what the best method to answer that question is and your expertise. We don't have a defined prescription in ours typically for space radiation.
On the opposite end of the spectrum for HHC, we prefer humans. There is no definite prescription. Any and all can be used, but order of importance is human, animal, and then down to cells.
And this is Sandra for HPP. We tend to focus more on humans. We've had some calls that call out an animal component, but for the most part, it's humans that it should specify if it deviates from that in a topic.
Great, thank you. Do I need to specifically indicate new investigator or ECI status? I think we addressed that. From Vlad, if DRD will be used, where should the subject for this research be recruited from? How does this relate to their remuneration if government personnel? Mike, do you want to talk on that?
No, it's a really good question, to which I don't know the answer. I think it would be very challenging to recruit subjects from outside of the Dayton, Ohio area and try to fly them in. I think you'd probably want to try to recruit locally, but I wouldn't lock that in stone. that's one we may have to think about, and we may have to post in the frequently asked questions after the fact.
Great, thanks. From Jacob, can you explain more of the difference between the early career and the new investigator? The main difference between those two is new investigator is just anyone who hasn't had NASA funding in the last 10 years. The early career is also someone who has not had funding in the last 10 years, but has also graduated from their terminal degree within the last 10 years. So this is early career is designed to get people in an earlier stage of their career, as it says. New investigator can be anyone. So it could be someone who's a very senior scientist in their field, but just has never written for an HRP or NASA grant in the past. For Appendix F, can proposers be non-US citizens? I'm not quite sure the answer to that. Manish, do you know that?
Sure. Yes, they can be non-US citizens as long as, and they'll be eligible for NASA funding as long as they're affiliated with a US institution.
Okay, great. For Appendix F, new investigator, step 1 application, is it mandatory to include statistical overview? So for the step 1s, you have a maximum of 1 page. So just a brief description of the statistics is probably all that's necessary. For the step 2s, you would be required to have an entire statistics section. Do the element scientists agree with this?
I'd say that you don't need statistics for the step 1. Step 1 is just for relevancy. So just tell us what your idea is, what your aims are, what question you're trying to answer, and how you do it. It's very, very simple.
I would concur with that, Mike. This is Robin from Space Radiation. I think if statistics are going to be a major part of what you are doing, for example, the computational modeling with the brain stuff that we're asking for, that I could see statistics being a very large part of the overall approach. I would say definitely include those statistics as part of the approach, but really the main point that we look at for our relevancy review is that significance of how you are going to address our needs as the program. So that is what I would tend to focus on.
Yeah, this is Sandra. I agree with both Robin and Mike. I think the laying out your idea and the conceptualization of your science, how you plan to, at a high level in that step 1 is important. And not so much the statistics till you get to the step 2.
Great, thanks everyone. Is a private company PI that is collaborating with a university eligible for the new investigator opportunity? Yes, as long as they meet the criteria that we've discussed previously. Next one will be fun. Will the NASA JSC IRB committee have primary oversight over the protocols? And is there an Air Force Navy IRB on site that will have additional oversight? Mike, do you know the answer to that, or is that going to be a TBD?
With the recent changes with the NASA IRB, I don't know the answer anymore to that question. So that's going to be a TBD.
Great, and the next one is for you also. The Kraken seems like a semi-requirement, yes?
Negative. Is not a requirement. You're free to use if you have a way of testing a G transition and evaluating countermeasures on your own, you're welcome to propose it.
Great, thank you. I think we've already covered the statistics. For Appendix E, are there support facilities for baseline data collection on site or close to DRD? Mike, do you know?
Yeah, my understanding is that that is a research facility. So it's a pretty big place. So my assumption is that yes, that all that will be available, and that they should probably have support to help you recruit local subjects. Now that I think about it.
Great. Who reviews whether pre-proposals result in invitation for step 2, NASA folks or outside NASA folks? That's done by the element scientists in the program science office. Can a PI submit 2 step 1 proposals? Yes, you can. Yes, for F, as long as they're different proposals. You mentioned that this is not NIH in space. With drug development towards mitigation of identified risks be outside the scope of an Appendix F proposal. Given my experience with drug development, I can't imagine how you could do that for $150,000 or in 1 year. But if it addresses a risk, then it might be considered. If an Appendix B proposal was not chosen for funding, can the Appendix F proposal be a revised version of the Appendix B proposal? Not within the same solicitation, but if you had one from a previous solicitation that you're modifying to meet the criteria, I believe that would be allowed. Manish, can you think of a reason why that wouldn't be allowed?
That would be allowed, and then the only caveat there is that you would need to address the previous reviewer's comments.
Right. About brain modeling, are you looking for specific types of modeling? I mean, kinetic, machine learning, metabolic. Can a new investigator submit a proposal for brain modeling?
Sorry, couldn't find my unmute button. Not looking for a really specific type of modeling. And can a new investigator submit absolutely a new investigator can submit a proposal for brain modeling. In fact, I would encourage new investigators to submit a proposal for brain modeling.
Great, thanks, Robin. Is there possibility of access to NASA-associated ground non-flight resources for these projects, especially for new investigators? Data sharing is always possible. Access to data from the LSDA, as long as you specify that, are things that are available. I'm not sure what else you might be referring to for non-flight resources if you're talking
Steve,
about.
I'll jump in here just to,
Okay, sure.
to plug our, for space radiation, we also have a tissue sharing database.
Yes, there you go.
As, so if you're, for the Omnibus calls, those are always really a great place to do tissue sharing because of the limited resources. So if you look at LSDA, which is something that Steve just mentioned, there should be an NSRL, NASA Space Radiation Lab, tissue sharing biospecimen link in there that you can look at all the tissues that our previous space radiation researchers have archived and can be made available for future research.
Great, good call. That's excellent. We're always trying to utilize as many resources as we can and get a good bang for the buck. So thanks, Robin. Who evaluates step 1 proposals? Is this NASA internal or external? As I mentioned, it's NASA internal. It's the elements and the program science office do that evaluation. Is support for using the NSRL facility underwritten in the Omnibus? Robin?
Yes.
Yes.
Any proposals that are done under space radiation that use NSRL, space radiation sponsors the facility costs for that. So don't worry about that.
Excellent. Next one, for the computational brain modeling topic, would inclusion of irradiation of instrumented phantoms for computational model validation be considered non-responsive? I see that in vitro and in vivo irradiations are considered non-responsive. Robin?
That is a really good question. For instrumented phantoms, I would have to say it will depend on how you sell that. I'm definitely not going to throw it straight out for being in vitro and in vivo. So I would say, yep, that would be considered responsive. Just be very specific as to the relevancy and lay it all out.
Excellent, thank you. For Appendix E, what are the constraints of using equipment, physiological evaluation, performance monitoring, countermeasures in DRD? If not applicable, estimate when will this information be available? Mike, any clue?
Yeah, we're currently actively working that agreement, so we don't know the degree of modifiability and what equipment you'll be able to add to this device. So for step one, I would not worry about that part, and hopefully by the time we're working on step twos, we'll have all that information available.
Great, thanks. And then do you expect preliminary data for the step two? For Appendix E, yes, I would expect preliminary data. For Appendix F, which is an omnibus, we don't necessarily expect preliminary data. For Appendix F, new investigators, in the step one application, will studies which are conducted without using space analogs be considered as relevant if they are, I'm assuming that's using the longer term 2 years, addressing NASA identified risk? What if the first year of a study will focus on terrestrial studies using a technology device, following which the said technology will be applied for space analog studies? That's a long question.
So I'll jump in on this one just
Sure.
for from the space radiation standpoint, because I know space radiation is one of, and we're talking about Appendix F, right? Oh my God, these questions keep coming, so I keep losing my spot.
I know, it's hard to track, isn't it?
Yeah, so for Appendix F, yeah, so these are omnibus for us for space radiation. Our analog is NSRL. We completely understand that NSRL is not necessarily feasible with an omnibus solicitation, given the limited resources. And so as long as you provide strong, justifiable rationale of why you're not using that space analog, we're okay with that. You just have to provide us the justification. That is the most important part. You have to sell it to us. You can't leave it to us to make up that justification for you, because we will get it wrong. So from the space radiation aspect, that is what we expect. But I can't speak for any of the other elements.
Just as a quick note, Appendix F is the omnibus opportunity, and those are 1-year opportunities. You should not plan as though you will be granted a second year. I think that's in the solicitation.
Mm-hmm.
So give your first year in your proposal.
And this is Sandra. We do get some omnibus proposals that come in proposing to do studies in para or longer duration analog, and that is not feasible within that time period. So we request that a different approach be considered when proposing an omnibus. Has to be feasible within that year.
Great, thanks, Sandra.
This
Robin,
is Chris.
you want
Can
to
I
take
jump
that?
in?
Oh, sure, go ahead.
Thanks, Steve. From an XMC perspective for technology development projects, most of those begin terrestrially, and then subsequent work over time may involve an analog, but initial development is always related to terrestrial studies.
Thanks, Chris. I have to scroll back up since a few more have come in. For radiation effects, what is the view of radiation type, i.e. how close to space radiation do we need to be if submitting under Appendix F? Is there a preference for, say, proton beam versus X-ray? Robin?
Perfect. So again, for Appendix S, because this is the Omni, as long as you provide a clear justification as why you're using that proton beam versus the X-ray beam, you may have some compelling argument for why you're using the X-ray beam. That is totally fine. If you have access to a proton beam and you want to use that proton beam, as long as you have a justification and a compelling argument for why you're using that proton beam, just make that case. So I'm not going to tell you if I've got preference for one or the other, because I don't necessarily know what it is that you're proposing and what your justification is for that. So all I can say is make sure you have a rock solid rationale and really lead us down that garden path and make us understand why it's important for you to be using this, whether it's historical data that you're matching to or whatever. So those are my thoughts.
Great, thanks. The next one I think is yours too, Robin. Do you want to answer that? About the modeling of brain. Are you looking for computational tools to help understand available data sets, or are you looking for models that drive experimental design? And the research should include the possibility to perform experiments.
I would say it's more of option one is looking to help understand available data sets. Of course, I think the development of such a model would eventually drive the possibility of developing hypotheses to test in an experimental setting, but this is really more focused on using available data sets. And maybe combinations of novel data sets that are, or not, maybe not novel, but different data sets that haven't been used together before.
For the next question, the describe the DRD, I would refer you to Google, Google the Kraken, and then you can watch some pretty interesting videos to see what it's capable of.
Excellent, thanks, Mike.
I can imagine the excellent Google searches people will get if they just Google the Kraken.
Right. So if we want to request year 2, will we have to submit a new proposal after the end of year 1, or should brief expectations for year 2 be included in the proposal? I think Ben kind of covered this just a few minutes ago. Just address the first year in your proposal. If there should be exceptional progress, the second year would be worked out with the element in question. Next question, we plan to use space analogs from second year on, so will the first year study, which will focus on collecting preliminary data in a terrestrial setting, be considered for funding? I just heard someone comment, so initial development related to terrestrial studies will be considered for funding, right? Anybody?
Yeah,
This
so
is-
this, oh, sorry. Go ahead.
I was just going to say, I presume this is coming from the comment that I made just a moment ago. This is Chris from XMC. If initial technology development is focused on terrestrial subjects or terrestrial studies for its development purposes, then we would consider that for funding.
And this is Sandra. If the comment was tied to the discussion around studying in analogs and that not being feasible in a one-year omnibus, I think that the one-year omnibus proposal needs to sort of stand on its own in terms of a objective with deliverables and again, additional consideration we have to be given down the road for continued work.
Thanks. Appendix E, will NASA, Navy develop Artemis-specific DRD simulations with relevant gravity conditions? When will this information be available? It would be most useful for proposal development and statistical considerations. Mike?
That's a good question too. So, you know, they haven't down selected the lunar lander company yet. So once that happens, we'll have more information on what their landing profile will look like. I think for now, I think the answer is we don't have those details right now. So we'll have to add that. We'll have to add that to the FAQ at the end. But like I said, we're working on negotiations with both the commercial landing providers as well as the Navy, and we just don't have the information yet. And I'll sort of repeat what I said earlier, that I don't think that information is necessary for step 1 currently, but hopefully we have everything available in about a month to be able to help you develop step 2s.
Great, thanks. Can Appendix F proposals include the use of microgravity flights, parabolic or suborbital? The way I'm going to address that to say it would be very difficult. We don't control those flights. As I mentioned, they're done in France and they don't happen every year. That being said, we have funded one in the past as a omnibus, but it is not usual. I think that's the fairest way to describe it. Looks like someone's been looking at the videos already of the Kraken. He says it looks like it only has one seat, but the solicitation states it accommodates 2. Can you confirm, Mike?
Yeah, my understanding is they're modifying it so that it will have 2 seats.
Great, thanks. And then when will the FAQ be uploaded onto Inspires? Ben?
So usually we will transcribe and then confer with the NASA folks to make sure that all the answers are complete and have all the information that they feel would be helpful. So it takes a couple days. I would imagine that it would be up by Monday.
Great, thanks. We have 1 minute left. Are there any more questions that you can type quickly? All right, seeing none. Thank you all very much. Appreciate your participation and all of your questions. Some really good questions in there. So good luck writing your proposals, and I hope to talk to you all again soon. Thank you very much.
Thanks, everyone.